Sea level may seem like just another number, but it's actually one of the clearest signals we have that Earth's climate is changing. With every millimeter of ocean rise, our planet is telling us something. And now, thanks to NASA's satellite observations, we can explore sea level data more clearly than ever before. In this tutorial, we're going to explore NASA's global sea level data, how it's collected, what it reveals about our warming world, and how you can access and analyze it yourself, whether you're a GIS analyst, student, or climate educator. Let's begin with why sea levels are rising. Scientists identify two major drivers. The first is the melting of glaciers and massive ice sheets in places like Greenland and Antarctica. As this ice melts, it adds fresh water directly into the oceans. The second factor is thermal expansion. As water warms, it expands. This increase in volume causes sea levels to rise, slowly but steadily. Now here's a striking fact. Since 1993, global sea levels have risen by about 100 millimeters. That's 10 centimeters, roughly the height of a coffee cup. It may sound small, but this rise is happening across the entire surface of the world's oceans, and it's accelerating. NASA tracks sea level rise using satellite missions managed by the Goddard Space Flight Center. These satellites use altimeters to precisely measure changes in sea surface height over time. This data is incredibly valuable, giving us a near continuous global view of ocean changes month by month, year after year. Let's look at what this data actually shows. The first graph presents satellite measurements from 1993 to the present. It shows a clear upward trend in global sea level. As of April 2025, the rise totals 99.5 millimeters, with a margin of error of plus or minus 4 millimeters. While there are small seasonal fluctuations, the overall pattern is unmistakable. Sea level is rising, and the rate of change is increasing. To understand longer-term trends, NASA scientists combine satellite data with tide gauge measurements that date back over a century. This is where the second graph comes in. The second graph extends from 1900 to 2018 and includes both coastal tide gauge and satellite data. From 1900 to about 1950, sea level rise was slow and gradual. But after 1990, the trend steepens, showing a much faster rate of increase. This acceleration is largely due to intensifying ice melt and warming oceans, direct effects of human-caused climate change. This graph also shows the different factors that influence sea level rise or fall. You'll see plus signs where rising influences occur, like mountain glacier melt, Greenland and Antarctic ice sheet loss, and thermal expansion. You'll also see occasional negative influences like major dam projects that temporarily stored water on land instead of in the ocean. Now let's say you want to explore this data yourself. Start by visiting the NASA Climate Vital Signs page on sea level. The address is climate.nasa.gov/vital signs/sea level. To download the full dataset, you'll need to create a free Earth Data account. Simply go to urs.earthdata.nasa.gov, sign up with your email, and once your account is verified, return to the sea level page and click the Download Data button. The dataset includes a range of variables listed across 13 columns. These columns are labeled as HDR1 through HDR13. The data starts with metadata like altimeter type and the cycle number of the satellite observation. It then includes the time of measurement, the number of observations used, and the variation in global mean sea level, both with and without adjustment for land motion, also known as GIA or glacial isostatic adjustment. Some columns show the raw sea level change, while others show smooth versions of the data using a 60-day Gaussian filter to remove short-term noise. There are also versions with annual and semi-annual seasonal signals removed to help clarify long-term trends. Once downloaded, you can import this data into a data visualization tool. Thanks to open access data from NASA, we now have the tools to explore, teach, and act on the truth that our oceans are rising. And as GIS professionals, educators, and students, we have the responsibility and the ability to use that knowledge for good. The sea is rising, the data is here, and you now have the tools to make sense of it.